Welcome to Beyond Words, the new frontiers of computational linguistics. Today's episode highlights insights from 38 cutting-edge research papers exploring the intersection of language, artificial intelligence, and human connection. Discover how machines are learning to understand us, with breakthroughs in privacy, inclusion, and safety, as we embark on a journey through the most vital areas of computational linguistics research. In this guided tour of computational linguistics' latest advances, listeners will gain an understanding of why language technology is more important now than ever. The episode covers the key research themes shaping the field in 2025, explains technical breakthroughs in accessible terms, highlights 3 influential studies, and offers a forward-looking perspective on where the next wave of research is headed. Computational linguistics lies at the heart of human-AI communication, representing the science and engineering behind computer understanding of language. This discipline powers crucial technologies such as translation systems, summarization tools, and voice assistants. By bridging cultural and linguistic divides in our increasingly digital lives, computational linguistics integrates computer science, linguistics, and artificial intelligence to drive inclusivity, access, and innovation on a global scale. The first major theme is the evaluation and benchmarking of language models. Reliable assessment is essential to ensure machines truly understand and can be trusted. Recent work includes Go and colleagues' modular benchmarks for scientific agents, termed Dr.Mi-Bench, and Maheshwari's IndicParam, which targets low-resource languages. These benchmarks emphasize not only accuracy, but also deeper reasoning, consistency, and real-world resilience, reflecting the evolution of evaluation methods beyond simple checks. Such efforts are critical for ensuring the safe deployment of artificial intelligence. Theme 2 addresses multilingual and low-resource language processing, aiming to close the digital language divide. Joshi and collaborators have developed ELR-1000, a dataset for endangered Indic languages, while Blostak's team advances conceptual dictionaries for Slovak, and Coffee introduces fast POS tagging for Bangla and Hindi. While translation pipelines offer temporary solutions for underrepresented languages, there is an urgent need for more native resources to ensure true inclusivity in language technology. Safety, trust, and robustness in language models constitute the third theme. Recent studies, such as Ahmed Ananto et al.'s work on measuring semantic confusion in model refusals, Zhang et al.'s auditing of vulnerabilities under real-world perturbations, and Ren et al.'s analysis of privacy evaluation gaps for text anonymization, underscore the importance of trust building through nuanced safety metrics. The integration of human-centered safeguards is now central, ensuring AI systems remain secure and sensible in diverse contexts. The fourth theme highlights advancements in model efficiency and human collaboration. Tian and collaborators introduce parameter-efficient fine-tuning with EffiLoRA, while Hossein Opi explores mixed precision computation for Bangla NLP. Khan's research presents multi-agent tournament-style response optimization, and Agrawal advocates for interactive visualization tools and error detection. These innovations make models smarter, leaner, and more reliable, with collaboration enhancing adaptability and overall system robustness. Key findings shaping the field include the democratization of language technology through efficient fine-tuning methods, as demonstrated by Tian et al. Translation pipelines provide interim support for low-resource challenges, but do not fully address the underlying issues, as noted by Shivaprasad et al. Thangda's work reveals that thoughtful schema design can surpass mere model scaling and reasoning tasks. Multi-agent frameworks, according to Khan et al., outperform single model outputs, while Ren et al. Emphasize the necessity for privacy and safety metrics that align with real-world legal and user requirements. Recent advances have been achieved through a diverse methodological toolkit. Parameter-efficient fine-tuning, known as PEFT, enables model adaptation with minimal computational resources. Custom benchmarks, including Dr.Mi-Bench, IndicParam, and CryptoBench, rigorously assess real-world tasks. Prompt engineering allows for precise guidance of model outputs, while human-in-the-loop techniques incorporate user oversight to build trust. Multimodal and multilingual alignment methods facilitate learning across languages and data types, broadening the applicability of computational linguistics solutions. The first featured paper, authored by Ren et al. In 2025, systematically reviews 47 papers and 6 distinct privacy notions related to text anonymization. The study finds significant misalignment between commonly used metrics, legal frameworks, and actual user needs. Concepts such as k-anonymity, differential privacy, and semantic privacy are shown to address different risk profiles. The authors call for explicit metric selection and alignment with both legal and user expectations, setting new standards for robust and trustworthy privacy research within the field. The second spotlighted study is Joshi et al. 2025, introducing ELR-1000, a community-generated dataset covering 10 endangered Indic indigenous languages. The dataset comprises over 1,000 traditional recipes, each enriched with cultural context. The research reveals that current language models struggle with accurate translation and comprehension in these settings, but performance improves when context-aware prompting is applied. This work establishes a new benchmark for inclusive and culturally grounded natural language processing. The third highlighted paper, Ahmed Anonto et al. 2025, focuses on the phenomenon of semantic confusion in large language model refusals. The researchers introduce the Paragard corpus, featuring 10,000 controlled paraphrase clusters, and develop new metrics: confusion index, confusion rate, and confusion depth. Their findings reveal that aggregate refusal rates often miss local inconsistencies. This work provides essential tools for auditing and improving AI safety, fostering more sensible and trustworthy language models. Looking ahead, the future trajectory of computational linguistics is shaped by several priorities. These include the development of community-driven resources for underrepresented languages, the alignment of privacy and safety metrics with both legal standards and user values, and the creation of benchmarks capable of probing deeper reasoning and robustness. Multi-agent and human-centered design approaches are expected to enhance trustworthiness, while increased transparency, improved governance, and real-world impact remain central to the field's evolution. This synthesis was generated using GPT 4.1 by OpenAI, with voice narration by DeepGram TTS and visuals produced through OpenAI tools. All content has been reviewed by a human expert for accuracy and clarity, though some oversights may persist. For comprehensive details, refer directly to the cited research papers. All references and sources are transparently provided to ensure accountability throughout this synthesis. Thank you for joining AI Frontiers. If you enjoyed this deep dive, subscribe to our YouTube channel to stay updated on breakthroughs in AI and computational linguistics. Join a global community passionate about language and technology. Comment, share, and suggest future topics. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.